I was born in a city called Kottagudem in India. It's in South India in a state called Telangana.
What did you do in summary in your PhD years?
So I'll start off by saying that the subfield of astrophysics I work in is known as Galactic Archeology.
Very cool, Annie. So what was the biggest discovery of your research?
So by applying this technique to one of these galaxies, I was able to show that, instead of being this big, the relic galaxy, it was like this big.
And for some of the viewers that might not know what dark matter is, can you just maybe quickly define dark matter? Hello everyone, welcome to another episode of PulsarTalks, where we interview researchers around the world in 10 minutes or so. Today I'm with Anirudh Chiti. He got his PhD in physics at MIT, and now he's a postdoctoral researcher in the University of Chicago. Welcome, Ani.
Thank you.
I'm gonna start with an icebreaking question. Where were you born? What city?
I was born in a city called Kottagudem in India. It's in South India in a state called Telangana. It's a small-ish town, I think, by the standards of India. It has 80,000 people, and its main industries are coal and natural gas, I believe. I think mainly coal. Yeah, that's where I was born.
Nice. Any food that is famous in your town?
I don't know about food that's famous in my town, but food in the capital city, Hyderabad, where most of my family is now. It's famous for its biryani. I don't know if you've had it.
Biryani. I should try it.
Yeah.
So, Annie, I think I know that you have worked on astrophysics, but I don't know fully about the details. Can you share with us what did you do in summary in your PhD years?
So I'll start off by saying that the subfield of astrophysics I work in is known as Galactic Archeology. And that's basically what the name says. It's very, sounds similar to what the name is. Basically, I look for ancient stars and ancient galaxies that are nearby or within our own galaxy, the Milky Way. And by studying these ancient stars and galaxies, I try to understand what the properties of the first stars and galaxies to have formed in the universe may have been. As you may imagine, these ancient stars, which are known as metal 4 stars, are actually really rare. They have to survive for 12 to 13 billion years to exist today. So a major hurdle in this field is, how do we find these stars? And so for my thesis, I developed techniques to identify these stars very efficiently from imaging. So there are large imaging surveys, they're called, of the southern sky, where a lot of images are taken tiling the whole southern sky. And through these images, which are public, I was able to increase the efficiency of finding these ancient stars, which opened up new possibilities for research directions in these fields.
Very cool, Annie. So what was the biggest discovery of your research?
For context, when most of us think about the Milky Way galaxy, we think about the image of these very blue spiral arms, a disk of stars. It's called the galactic disk. But that structure of stars is actually just a small component spatially of our galaxy. So if we look at the Milky Way as a whole, that disk of stars with those spiral arms is actually embedded within a larger halo of dark matter, whatever dark matter may be. That's about 10 times the length of the Milky Way spiral arms. And so when I say halo, I mean like a spherical distribution. So it's like there's a blob of dark matter, and embedded in the center is what we think of as the Milky Way. And within this blob of dark matter, there are also other smaller galaxies. And some of these galaxies only have a couple of thousand stars, and all of their stars are something like 12 to 13 billion years old. So we think these systems might be relic galaxies that formed really early on in the universe that just sort of are surviving today around the Milky Way. And so it's really difficult to study these galaxies, as you may imagine, because there are so few stars, and they just kind of blend in with the stars along our line of sight in the Milky Way. So if you have a way to really efficiently identify these ancient stars, these metal 4 stars, you can start to identify more stars that belong in these primitive galaxies that you wouldn't have been able to see before, because they'll be covered up by the foreground, by Milky Way stars along our line of sight. So by applying this technique to one of these galaxies, I was able to show that, instead of being this big, the relic galaxy, it was like this big.
Wow.
So this relic galaxy it basically had a structure of stars that was puffed up around it, basically a factor of 5 more spatially distant. So much like the Milky Way inhabits this halo of dark matter, which is studded with stars, it seemed like this relic galaxy also had some sort of halo of dark matter around it that was studded with primitive stars relative to the galaxy as well. And this was the first time we had seen something like this in one of these surviving galaxies.
It's so wonderful, Annie. And for some of the viewers that might not know what dark matter is, can you just maybe quickly define dark matter?
Oh, yeah. So dark matter is basically a placeholder term for matter or some sort of modification of gravity that's needed to account for the fact that galaxies around us seem to have something that's binding them together that's not visible matter, that's not luminous matter. And we can go a step beyond that, and based on evidence from Big Bang nucleosynthesis and other galactic clusters, it seems as though this matter, if it is matter, is not baryonic, which means it doesn't interact through the light, through the electromagnetic force or through the nuclear forces. It only seems to interact through gravity with regular matter and with itself. And it makes it very difficult to study, and so we don't know what particles it could be. There's a lot of work in trying to figure out what that could be. But basically, it's kind of like glue that seems to exert gravity and hold structures together in the universe. And there's some debate about whether it's matter or whether it's a modification of gravity that's needed.
So your field, Annie, is so fascinating to me, and I'm sure for a lot of viewers. I'm curious, why did you go into this field? How did you choose this one?
I think it was luck. So I think a lot of people are interested in space. Maybe not a lot, but people I talk to, when they're, there seems to be some interest in astronomy and astrophysics and black holes and how did we form and stars and galaxies. And so I was no different when I was young. My favorite shows on TV were always Nova science documentaries about the universe. I enjoyed going to the planetarium and seeing all, everything in the sky. But I think I wouldn't say it was an exceptional interest. Like, I was very interested in these things, but I knew friends that were more interested in these things. And so when I applied to college, I put down that I was interested in physics, because I didn't know what else I was really sort of drawn to, with the full expectation that I might switch out of physics and do engineering later on. And then I began doing physics. I enjoyed my physics courses. I tried to get a research position in undergrad in a particle physics lab. All the particle physics groups were full, so I began working in an astronomy lab. And then the second astronomy project I worked on, I had a wonderful mentor, and it went really well. And I think this really taught me that observational astronomy research, so to clarify, I do observational research, involves a skill set that I don't think the public really associates with astrophysics, which is you have to be able to analyze data with programming, and it's a bit different than the public conception of Sheldon Cooper and the Big Bang Theory. In the sense that you have to be you have to work with people, you have to think about these big questions in a bit more of an empirical way. And I never thought that would work well with me, but it did, and I was very lucky to have that mentor. Then I applied to graduate schools, I got into PhD programs, and I always found questions of how the galaxy formed to be very interesting, or how we all came to be, and so I began working with my advisor on this topic. The other thing too was I got along well with my advisor, and that was a major decision why I went into this field. Is someone told me that how well you get along with your advisor will determine how much you enjoy your research and your PhD. So we got along well, and so I also went.
I tend to agree with that a lot. The role of advisor is very important in PhD.
Yeah. So I think it was quite incidental, actually.
Very nice indeed. So as we are getting closer to the end of this episode, I wanted to ask a little bit more personal question about your personal experiences. What was one of the biggest challenges that you had during these years of your amazing PhD work?
So I think the most straightforward challenge is the fact that in astronomy, when you collect data over the course of your PhD, the weather determines whether or not you get data. If it's cloudy at the telescope or raining or snowing, the telescope can't open because the optics will get damaged and you don't get any data. For good reason too. I don't want the telescopes to get damaged. The way telescope access works in the US is also access-based. So MIT had access to the Magellan telescopes in Chile. And these are really big telescopes, and it's really a privilege as a graduate student to get as many nights in those telescopes that I did. But what was happening is, when my PhD really sort of took off and I was designing my own projects, from 2018 to 2019, every time I went to the telescope, about 5 times, the telescope never opened because it was snowing or raining or cloudy. And so I lost about, I think, maybe 9 nights at the telescope, basically 3 semesters worth of time, all of it. So that was a very straightforward challenge. And I think almost every PhD student I've talked to has gone through a period where they have to wrestle with the fact that their PhD may not be successful, or their PhD may not be what they wanted it to be when they first entered the program. And I very much had to grapple with those questions around this time. But luckily, I had one clear stretch of 3 nights in 2019, and that's when I made this discovery, and things began looking up after that, and my luck has reverted back to the mean. So.
Thanks so much for being with us today, Annie, and chatting with me today. It was a pleasure. I found it really fascinating. I wish you luck in the rest of your research.
Thank you. You too. It was really nice talking with you.
So, our dear viewers, please follow us on social media, and until the next episode, bye.